Welcome back to computer graphics and visualization subject. Today we will start a new module, that is module 5. In module 5 we are covering the topics input and interaction, curves and computer animation. These are the topics we are going to cover in module 5 as per syllabus, right? Then the course outcome of this module is explain curve generating concept and interactive computer graphics using the OpenGL. Means after learning this one, you will come to know that how to generate curves and how to interact the computer graphic applications with the input and output devices. Means interactive computer graphics you will learn, right? Then today we are going to discuss, basically in this module we are covering different, means this syllabus covers different concepts. One is input and interaction, curves and computer animation. Among these three concepts, today we will start with input and interaction concepts from module 5, right? Then what is input and interaction? Objectives are to learn about introducing variety of devices that are used for interaction, right? Then learn about two different perspectives from which the input devices are considered, right? The one purpose of the input devices we have discussed in first module, right? That is physical properties of input devices. In first module we have discussed input and output devices. In that module we have discussed the physical properties of those devices. Then working of those devices, right? The way that the physical devices can be described by the real world properties, that part we have discussed in the first module. Means how that device is formed, then how to use that one, how they will work, though that part we have discussed, right? Then the way that these devices appear to the application program, this part we are discussing in this module, right? The second point of those, means second characteristic of those devices we are discussing in this module, the way that these devices appear to the application program, right? We have seen in first module how they appear to the users, then how they work, right? That part we have discussed, but we have not discussed how the application program will treat these devices when you have interfaced to that application program. That part we have not discussed, that we are going to discuss in this module, right? Then input device, again input device is concluded. There are two different ways to look at the input device, that I told. There are two different ways we have to see the input device. One is physical device, one is logical device, right? Physical device is nothing but how physically they appear, how they work, right? How which are the characteristics of those devices, right? That is a keyboard or mouse, and discussed how they work. Already we have discussed how they work, keyboard and mouse. Most of the time we have used, means frequently we are using keyboard or mouse. Again, other input devices are joystick, right? Trackball, light pen. There are many input devices are there, but most frequently we are going to use keyboard or mouse in general daily usage, right? That part means we have to see those devices in two different. One is a physical device, how they look, how to use, how they work, right? That part we have discussed in first module. Now we are one more way of seeing that input devices is logical devices. One more way of looking those devices is logical device. In this, the way application programs look at the device, means when you are going to use that device in your program, how my application program treats those devices in the application, that part we are discussing. That is what logical devices means. We are discussing input device with respect to logical device. We are discussing input devices with respect to logical device properties, right? A logical device is characterized by its high level interface. A logical device is characterized by its high level interface with the user program rather than by its physical characteristics, right? Means logical device is characterized by its high level interface with the user program. Means when you are using that input device in your program, how to make use in my program so that I can use that device in my program, right? In that part we are discussing, rather than by seeing physical characteristics, right? Then logical devices. Now we will come to logical device, right? Means input device only, but those input devices we are considering as a logical device. Means I want to use those input device in my program, then how to use those programs, that part we are discussing here. The main characteristics that describe the logical behavior of an input device are the main characteristics that describe the logical behavior of an input device are what measurements the device returns to the user program. What measurements the device returns to the user program means once you interface any input device in your program, then what it is returning to your program, what data it is returning to your program, then when the device returns the measurements, then when that is going to return, to your program. Means basically proper characteristic of the character describing the logical device behavior is what input it is giving to your program, then when it is giving to your program, right? These are the characteristics or behaviors of the input device, right? In general, there are 6 classes of logical input devices. Means logically these input devices, they are classified in 6 groups. Input device may be same, but logically it may behave differently, right? Those are the, depending on those how they are behaving, what input they will give to my program, when they will give to my program, depending on those they are classified those input devices logically into 6 classes. First logical device is a string. First logical device is a string. First logical input device is a string, right? Then if that device, if you are treating as a string, if that device, if you are treating as a string, then what input it gives to my program, what input it is going to give to my program, so that that input I can use in my program to do some operations, right? To do some operations, right? String means, as you know, string provides ASCII strings to the user program. Means whenever you are using any input device as a string logical device, whenever you are using any physical input device as a string logical device, then always it is giving string as an input to your program. For example, keyboard. When you are using keyboard as an input device, the keyboard can be used as a string device. Logically, keyboard can be used as a string device. Means whenever you are pressing any key from the keyboard, it gives characters to my program. If I interface that keyboard in my program, definitely that keyboard as a string device. If I interface with that keyboard as a string device in my program, then whenever I press any key through my keyboard, it gives us characters. Then those characters I have to make use in my program, whatever reasons may be, right? Those characters I have to use. That is logically implemented via keyboard, right? Logically implemented via keyboard. Again, string can be implemented using mouse also. Mouse also can be treated as a input string device, right? In example, when you are treating that mouse as a string device, I hope all of you have seen nowadays the virtual keyboard is created on our systems. Always whenever you are doing basically in banking transactions, at that time they are giving virtual keyboards in desktop, right? At that time whenever you are press particular key, they are using a mouse, then those keys normally will press using a mouse. That time means mouse also can be interfaced as a string device logically, right? Keyboard and mouse can be interfaced as a string, but once you interface those devices as a string, then whatever input they are giving to your application program, for example, one application program you interface keyboard and mouse as a string device, then in that application program always they provide string as an input. Then those input you take in your program, then whatever operation you want to do depending on those strings you do, right? That is string logical device, logical input device. Then next logical input device, locator. Logical input device is a locator. Then what do we mean by locator? Provides a position on the word coordinates to the user program. Means if you are using any device as a locator device in your program, then the input from that locator device is always a word coordinate. For example, mouse. If you use a mouse as a locator device, as I told again, any device can be used in any logical device, any category logical device. Most of the time keyboard and mouse are used in all the categories, all the 6 classes. Mouse and keyboards can be used for all the 6 classes of this logical input device. That's why I am taking repeatedly, I am taking these 2 devices, right? Means whenever you are using mouse in your program, normally when you click any mouse on your monitor, then that mouse will return to your program the x and y values of that pixel values, right? Pixels are x and y. Means that is what provides a position on the word coordinates to the user program. Means if I use mouse as a locator device, always mouse will return the pixel values. That is the coordinates, right? Pixel values are rows and columns that will be written by locator, right? Again, keyboard also can be used to return the monitor coordinates, right? This is a locator device. Means if you are using mouse as a locator device in your program, then always after pressing that mouse, always input supplied by that mouse to your program is x and y. Then you take those x and y in your program, then you decide what you want to do by taking those x and y, right? That is the locator device. Then next, pick device. Picks, logical input device, is a pick device, right? What that pick device means? Returns the identifier of an object to the user program, right? Pick device returns the identifier of an object. For example, again, pick device can be mouse or can be keyboard. Again, pick device you can use as a mouse or keyboard. Then what is a pick device, right? Pick device is nothing but, I think all of you observed, whenever you go to any system, there are icons. Then whenever you want to click particular icon, first you have to pick that icon. Again, you can pick that icon by using a mouse, or you can pick that by using your keyboard, right? If you pick that any object on your means, it is going to pick some area. You cleanly observe whenever you are doing that operation, you observe that one, right? It will pick that area, right? Any icon, once you pick the any icon, then surrounding areas will be picked, right? That is what a pick device, right? At that time, it returns the identifier of an object. Every object, whatever object you are going to create in computer graphics, every object has its own identifier, unique identifiers, right? Whenever you pick n among n number of icons, particularly if you have picked WhatsApp icon in your mobile, assume that you have picked WhatsApp icon in your mobile, then WhatsApp icon has its own identifier, then that identifier will be returned to your application program where you are using that icon, right? Then taking that identifier in your program, you process whatever you want to process on that identifier, right? This is what pick device. Again, pick device may be pointer keyboard, or pick device may be a keyboard, right? Then next is a choice. Next is choice logical device. Allows users to select one of the distinct number of options, right? For example, drop-up menus. I think you have seen drop-up menus, right? Once you click one icon, then it drops so many options. For example, in a file, whenever you're using Microsoft Word, if you click that file, then in that file, new file, save as, all those things, those are the options. You will get those options. Then among those options, you will choose one choice. Right? Again, those have different identifiers. Those identifiers, respective identifiers, will be returned to your application where you are using this as a choice, as a device in your program, right? Allows users to select one of the distinct number of options, that is widgets, menus, scroll bars, and graphical buttons. Normally you have seen in your Word and Paint, all those things, right? That is a choice. Then next logical device is a dial. Right? Dial provides analog input to the user program, that is widgets and slide bars, analog inputs to the your program. Then next is a stroke. It returns an array of locations. Stroke is nothing but similar to your location device, but there is a slight difference between locator and stroke. Locator always returns only one value whenever you click. Whenever you are clicking, if you take a mouse and if you press here, then that x and y will be returned to your program. But in stroke, it returns continuous values of x and y. Whenever you are moving that cursor, it returns continuous values of your x and y. For example, in paint, when you are drawing any drawing on a paint, you will use a brush, that painting pen. Then what you will do normally, you will hold your mouse button, means you will press that mouse button, then you will drag that mouse cursor till you want to finish. For example, like this, if I go to paint like this. Now I want to draw something. What I will do, I will take that one from my mouse, I will press and hold that button, then I will drag, right? Then whenever I want to stop, then I will release that button, left button. Normally left button of my mouse I will release. What it has done, it has started here returning the value of x and y. It has started here till this point, it has returned the value, that is a stroke, means array of pixels it has returned to my application. then whenever it has written that, there I have drawn this line. This is what is stroke. But in point case, what happens? In locator, only one time I will press and I will leave. Only one time I will press and I will leave. That is what locator. Only one time it will give the x and y. But in a stroke, it gives array of x and y, which starts at this point. Means which starts at this point. Then I will start dragging this one. Then it is returning the x and y continuously, right? Then once I release, then it stops. This is what a stroke, right? Then I have told menu, that is this, like this. That is what? This option. That is choice. Choice is nothing but whenever you pick any option, at that time here only you can see, if I pick this one, design, then it gives these are the options, right? If I then if I pick the file, then these are the choice, right? Any choice you can pick here, right? Like this we have the option, these are the, like this they will work, right? Then I have told pick is nothing but like this. Pick is, for example, if you go here, if you go to monitor, then if you want to pick this one, you will pick. It will cover some portion of your monitor. This is what a pick. At that time it has, means that file has its identifier. That identifier will be returned to your program. That you have to take and that you have to use. Right? These are the working of devices. Means most of the time we will use mouse and keyboards for using. These are the logical, as a logical device. Right? This is what the categories of logical device. Now means logically they are classified like this. Right? Logically they are classified like this. Those what are the classification? You can use that input device as a string logical device. You can use as a locator logical device. You can use as a pick logical device. You can use as a choice logical device. You can use as a dial. You can use as a stroke logical device. Right? Then next is measure and trigger. Then how these will work normally? How these will work in a program level? How these will work in a program level? Right? The manner by which physical and logical input device provide input to an application program can be described in terms of two entities. Means how they are giving input to your program. When you use the keyboard and mouse in your program, then how they will give input to your program. At what time input is available, what type of input is available, right? That is this measure and trigger will describe, right? A measure process and a trigger, a device trigger. What do we mean by measure? Measure. The measure of a device is what the device returns to the user program. A measure is nothing but a data. Means what data it is returning to your program. When you use the keyboard as a locator, when you use keyboard as a locator device, then what input it gives to your program? What input it gives to your program? As I told in the locator, only it gives x and y. Only it gives x and y, that to integer. Only that to integer, because pixels are in integer. There is no floating point pixel values on a monitor. Always it gives integer. What data it gives, what type of data it gives, everything will be measure, right? When you are using any device as a particular logical device type, if you are using a stroke, then that time it is giving a continuous values of x and y, array of x and y coordinates in the measure. But if you are using as a locator, that device as a locator, then measure is x and y, that is the integer, that is the coordinates, that is the coordinate of your monitor, that is what measure, right? Then trigger. The trigger of a device is a physical input on the device with which the user can signal the computer. Means when it returns that input, it is returning x and y. To my program, if I use mouse as a locator device, it returns x and y as an integer. But when it returns to my program, that will be trigger. Means most of the time mouse returns input to your program when you release that one, when you release that left button, right? Means at what physical operation of that device returns, that is what a trigger, right? Definitely it is giving some data, but at what moment, right? When you are pressing that time or when you are releasing that button. For example, if you are using a mouse left button you are using for returning as a locator device, right? Then when it is returning, whether it is returning that input during press time or during release time, that is what a trigger, right? Physical operation. At what physical operation that data it is releasing to your program, right? That is what a trigger. Then next, measure and trigger. For example, example 1, the measure of a keyboard is a string. For example, you are using keyboard as a string device. You are using keyboard as a string device. Normally the measure is a string. Means for example, you want to give your input to your program. Then what is your input? Input is characters. That is a string. Then when that input will go, when that input will be taken, the trigger could be the return or enter key. I will give best example. For example, you are using scanf in your C program. You are using scanf in your C program. Then you are reading a string. Through that scanf function. Right? First you will write your first letter of your character, your name. First you will type first character of your name. After pressing first character, is your program accept that input? No. Then you will type next character. Still it has not received your input. Only it receives your input once you press enter key. That is the trigger. What is a measure? Your name is a measure. Then trigger is enter key. Means only unless and until if you press enter key, that measure will not be taken to your input device. Your application program will not take that input. That is what the measure and trigger. Example. One more example too. For example, if you are using a locator as a measure inputs the location. Means if you are using that input device as a locator, as I told, measure is x and y. Means location on your monitor. That is x and y. Then when that x and y will be given to your application program, right? The trigger can be button on the pointing device. Means button press or button release. Right? Again, mouse can be used during the press time or during the release time. By default, the mouse will return its input to the application programs once you release that button. Means once you remove the finger from that button, pressed button, that time it is giving the input. That is what a trigger. Right? I hope you understood this concept clearly. Right? Then input modes. Again, these devices will work a different type of modes. Right? Input modes. There are different modes, input modes. Right? In addition to multiple types of logical input devices, we can obtain the measure of a device in 3 distinct modes. Right? Means you can obtain those input from the input device in 3 different modes. Right? As I told, measure is a data. Actually means if I give the analogy of data, measure with data, then measure is nothing but a data. This data can be taken to your application program in 3 different modes, 3 distinct modes. One is in request mode, one is in sample mode, and one is in event mode. Means this input, whatever input those devices are giving to your program, those can be taken in 3 distinct modes. That is, one is request mode, one is sample mode, one is event mode. Right? What this does, it defined by the relationship between the measure process and the trigger. These events will define the relationship between the measure and the trigger. Right? Normally, the initialization of an input device starts at measure process. Right? Initialization of input device starts at measure process. Means first we have to give the input, then we have to trigger. Don't trigger first, then don't give the input normally. Right? That's why normally this characteristic of input device is first we have to initialize the measure process, then afterwards trigger. Right? Then, right, one by one. Request mode. How? If then request mode, input device, how input device works in a request mode. Right? In this mode, the measure of the device is not returned. In this mode, the measure of the device is not returned to the program until the device is triggered. That is, best example is scanf. Means if you are using any scanf for giving a string, you will enter your name, but if you don't press enter key, then that input will not be supplied to your application. That input is not supplied to your input. Your program has to wait till you press the enter key. Your program has to wait till you press the enter key. Otherwise, it will not take. Right? This is what a request mode. Right? This is what request. Best example is scanf for reading a string. You will enter first character, still your program is waiting. You will enter second character, still your program is waiting. You will enter third character, still your program is waiting. It is waiting for a measure. Still measure is not received by your application. Still your measure is not received by your application. Only measure will be received by your application when you press enter key. If you don't press enter key, even though you have given all inputs, all characters of your name, but you have forgot to enter the enter key. Definitely that measure will not taken into your application. Only that measure will go to your application only once you press enter key. This is what request mode, right? As again as example, a locator can be moved to different points of the screen. A locator can be moved to different points of the screen. The Windows system continuously follows the location of the pointer. For example, locator, if you are using mouse as a locator, when you start moving continuously, the X and Y will be read by the operating system. It may be our Windows operating system may be monitoring continuously X and Y coordinates of my mouse, how it is moving, but only until the button is depressed. The location will not be returned. Right? This is what request. Working with the image measure means measure process will initialize, right? Measure will be supplied to the program, right? Program has to request for the measure. Means once you are using a scanf, then your program is requesting for the input from the scanf. It is requesting, then measure has to be supplied, but only when once you press the trigger process. Once you press the enter key, then only this measure will go to program. Otherwise, it is requesting, but it is unable to take that one until you press the trigger process. This is what request mode. Then sample mode. Input is immediate. In sample mode, input is immediate. As soon as the function call in the user program is encountered, the measure is returned. Hence, no trigger is needed here. Right? Here in this case, input is immediate. There is no waiting. Means it will not wait for event has to occur. Right? Immediately, as and when you call that function in your program, immediately that reads the measure. Right? For both of the above modes, the user must identify which device is to provide the input. Request locator, device ID and measure. Sample locator, device ID and measure. Device ID is identifier and measure may be location. Example measure. Think of the flight simulator which may many input devices. In this case, for example, if you are simulating a flight, at that time there may be n number of input devices. In that situation, the flight cannot wait for somebody to press some key. Because if somebody has went for having a cup of tea, if you don't press enter, then flight may crash. That's why in such situations, definitely they will not go for request mode. Definitely they will go for sample mode. Right? There is a measure process. Measure is coming continuously. Then sample it is requesting for sample. Right? This is what sample mode. Then event mode. The previous two modes are not sufficient for handling the variety of possible human-computer interactions that arise in a modern computing environment. They can be done in 3 steps. Means again, those two are not sufficient in real today's environment. Right? Means there should not be somebody to monitor. Right? I will do something, then I will go out. Then automatically my program has to take my input. Then it has to start processing in my absence. Right? If this is the case, then how to do this? Right? In this case, show how event mode can be described as another mode within the measure trigger paradigm. It shows how event mode can be described as another mode within the measure trigger paradigm. Learn the basics of client server when event mode is preferred, and learn how OpenGL uses GLUT to do this. Right? Here, what happens in this case? Already we are using this type of input in our OpenGL programs. We are using event mode input, providing input to our programs in our OpenGL. Already we have started, but you don't know how we are using it in this case. Already I explained in lab, but with respect to this concept I have not explained. Right? In an environment with a multiple input device, each with its own trigger and each running a measure process. Right? As I told, every device has its own trigger, every device has its own measure. Right? Each time that device is triggered, whenever you trigger any device, an event is generated. Whenever you trigger any device, an event is generated. The device measure with the identifier for the device, is placed in a event queue. Means first to place your measure in a event queue. Then press a trigger. Then that event will go and sit in event queue. The user program executes the events. From then your user program is keep on executing the events from the event queue. If there is an event, then measure will be there, then it takes that measure, then as per that it works that. When the queue is empty, it will wait until the event appears there to execute it, right? As I told, callback functions in OpenGL we have called callback functions. Means by registering those callback functions, we are registering those, means I am telling my OS that I want to use this callback function in my program. Whenever any request comes with respect to this callback functions in event queue, you process that. As I told, display callback, right? Display callback we have used. Then reshape, again we have used reshape callback, right? These are the functions, these are input and output devices I want to use in my program. Whenever any trigger comes from this, if there is an event in the queue, you process, right? This is what, in the absence of the program calling, in the absence of user, automatically does this one. Means every time your program monitors the event queue. If there is an event with respect to any input device, then what is the event that will be processed, right? If there is no event, then it waits for event has to be generated in the event queue, right? Another approach is to associate a function called a callback, as I have done. Means in OpenGL we are using callback function. Means associate all the functions as a callback function. Means make a registration in event queue. Then whenever any event comes from that particular input device, that event will be registered in event queue. If there is an event in event queue, during the process time, one by one our application may be processing. When that turn comes, that event will be processed, right, with a specific type of event. This is the approach we are taking in OpenGL, right? As I told, there is a program, right? There is an event queue. Then all measures will be submitted to event queue. Events will be there in event queue. Then program, operating system, every time it is monitoring the event queue. If there are events, then it will process those events, right? After trigger, that event will go and sit in event queue. After particular trigger, that event will go and sit in event queue. Then our operating system, every time it is monitoring the event queue, right? If there is an event, that event will be processed. If there is no event, then our OS will wait. This is what the third one, that is event mode. This is event mode. How, like this you can use any input device. Then next comes client server architecture, right? If a computer graphics is to be useful for a variety of real applications, it must function well in world of distributed computing and networks, right? Why this client server architecture plays very important role in computer graphics? Because as you know that most of the time we are consuming for refreshing the monitors. Our computer GPU, graphics processing unit, takes more time for refreshing, right? If that is the case, then in real world everything we are using in a client server architecture. Means most of the applications, most of the features we are making use as the client server architecture. Means already the programs are there, programs are available. Whenever I want, through my client system, I will execute that program in a server side, then server displays, server does that work. Since this environment today we are using the client server architecture, we have to use very efficiently in computer graphics applications, because whenever you want to redraw, every time if you are sending those commands through your client, then network will become busy, right? Again you will consume the bandwidth, right? Again there may be loss of data. These are the problems we will encounter when you are using client server architecture for computer graphics applications, right? In this word, the building blocks are entities called the servers that can perform the task for the client. Means already programs are available, right? There is a file server, there are graphics server, there are workstations, right? There are many servers, right, available, database servers. Then whenever we want, we will try to reach those servers, then we will execute that application, then we will get it done, right? In this case, whatever task I want to do from my client, just I will call that server, then I will tell my server that server to do this work, right? But when you are doing in computer graphics, we have to use this very effectively, right? That is the reason behind this. We have to discuss client server architecture right here. Then how to use efficient usage of this Then there comes a display list, concept called display list. How it helps us to make use efficient usage of this bandwidth or your standalone system. It is not again compulsorily for network only. Display list helps us to effective execution of program in a standalone system also, right? Display list illustrates how we can use clients and servers on the network to improve graphics performance. Display list will help us to how we can efficiently use the server and client architecture efficiently for computer graphics related applications. As I told, the most of the time our computer graphics programs will consume for refreshing the monitors. If you are using client server architecture, then if you are refreshing 500 frames per second, then 500 frames per second you have to transmit same set of commands over the network, right? If you are sending same set of commands over the network continuously, then you are unnecessarily wasting the bandwidth, right? Means you are unnecessarily wasting the resources of a network. This display list helps us to improve this performance of a computer graphics in a client server architecture, right? The computer would send out the necessary information to redraw a display at a rate sufficient to avoid noticeable flicker free, right? As I told, means if you refresh less, means if refresh rate is very less, then you may feel that flickers are coming on the monitor. If you retain the flicker free monitor on any of the application, then you have to send the necessary frame rate, right? This is in network. It is same case in the standalone system also. These will help to process this one. Means if you are drawing, for example, you want to draw one cycle, at that time what happens in a standalone system, you are drawing front wheel and back wheel. The size and the properties of both the wheels are same. At that time, unnecessarily drawing using those commands multiple times, use only one time. Then whenever you want to draw one more object with the same property, just you recall. It is like a function. In that, like this, it will help in standalone systems, right? In the past, since computers were slow and expensive, the cost of keeping even a simple display refresh was prohibitive for all but not few applications, right? Means buying the computer is very costly in olden days, right? The solution is to this problem was to build a special purpose computer called the display processor, right? To solution to this speeding up the process, display processor came into picture, right? Then host was there, then in a host system, then the same in the host system we have the display processor. That display processor was processing all our inputs. It is displaying on the monitor. Now when technology emerged, then today the display processor is graphical server. Means display processor, graphical server is nothing but a display processor. You just give the commands to the display processor, it does your work, right? No need to have the display processor in your host, right? And the user programs on the host computer is client, right? Through client you send the commands to the display processor, that display will be done on your monitor, right? We can send a graphical entities to display on one of the two ways. We can send this graphical entity to the display on one of the two ways. Again, for sending those graphical entities to display, there are two ways. Send the complete description of our object to the graphics server. Send the complete description of our object to the graphics server for a typical geometric primitives. This transfer consists of sending vertices, attributes and primitive types and addition viewing information. Means if you are preferring first method for displaying by the display processor, then every time you have to send all the information regarding that object, for example, if you want to draw one polygon, right, you have to send vertices, you have to send color, then you have to send the viewing of information, everything every time you have to send. But if you prefer this one, if you want to do this one, whenever you want to refresh, every time you have to send this. If you do this one, again bandwidth, it will consume more bandwidth, means it will consume the resources available in the network, right? That is what is the disadvantage of this, right? What is the disadvantage of this? Again, we have in both the case we have advantage and disadvantage, right? Then next is define the object once. Next method is define the object once, then put it at a description in a display list. Define only once, then put it in a display list. The display list is stored in the server, then display list is stored in the server and redisplay by simple function call issued from the client to the server. This method is called retained mode graphics, right? Then in previous case, every time you have to send, means you have to send vertex list, you have to send attributes, you have to send a primitive type, you have to additional viewing information every time if you have to send, if you prefer for first method. But if you do this one, every time you are consuming a bandwidth, means resources. Instead of going that one, you write those commands in a display list, then that display list is stored in a server side. Display list is stored in a server side. Then whenever you want to redraw that same object, just send one command to execute that display list. Only one line command is sent to the server saying that execute that display list, whatever is there in that display list. Right, automatically that display list will be sent. Means instead of sending every information every time, just only send one command to the server. Right, that is called retained mode graphics. Right. Then disadvantage associated with the use of display list. Again, disadvantage if you go for a display list. Right, if you go for a display list, advantage over first method, means advantage over the first method is if you use a display list, resending every time all information is avoided, means bandwidth consumption is very less in second case. But at the same time, you have disadvantage of this. What is the disadvantage of this? This is display list requires memory on the server, means you have to maintain exclusive memory for all the displays, means whatever object you want to draw every time, every object has to be created individual display list, then every object description has to maintain the display list, right? There is an overhead for creating a display list, means there is a overhead for, means you exclusively have to create those display lists. Automatically those display lists will not be created. Then one more disadvantage we have not mentioned here. One more disadvantage is if your every time state of your object is changing, then some of the displays may not change those state. For example, first time you have displayed that object with a red color, right? Then afterwards you want that green color. Afterwards you want that object in green color. If you have not done in your through client side, if you are doing that one in display list only, at that time again if you expect green side object, then that is not possible, because only once you have created that display list is static, right? Then definition and execution of display list. Definition, and then how to do this, how to use this display list in your program, right? Each time we used to draw the box. Assume that each time you used to draw the box on the screen on the server. Means you want to draw one box on the server. We execute a function gl call list box. Means there is a, I have already assuming that next we will say how to create a display list. Means I have created already display list already available in the server side. My display list is available in the server side. That display list, in that display list I am drawing one box. For example, simple one box I am drawing. Means all the commands, whatever commands I require to draw that box, all commands I have created as a one display list. Then that display list already I have stored in my server side. Then I want to draw that box. I have to draw that box on my monitor. Then whenever I want to draw that box on my monitor, I know that already display list I have created and I have kept it in my server. Just whenever I want to draw, just call that display list. Just call that display list to execute, right? How to call that one? There is API is available in OpenGL, that is GL call list. GL call list, then the name of that display list, because there may be n number of display list may be there. You might have created or others might have created, right? Then you have to pick which display list you want to execute. That's why for every display list there is a unique names, unique identifiers we have to assign. That's why we have given a box. Then automatically it calls that display list once you call only one command. Now instead of sending all commands over the network, only I'll send only one command saying that gl call list, then with the name of that display list. Only one command I will send. Automatically the commands present in that display list will be executed in order, in the same order. In what order you have written in that display list, in the same order all the commands will be executed. Then how to create that display list we will see in next slide, right, or in next video, right? Note that the present state of the system determines which transformations are applied to the primitive in the display list. Then present state of the system determines which transformations are applied to the primitive in the display list. Thus, if we change the model view, or projection matrices between the execution of the display list, if you change the model view of projections, if you change this any property of model view and projections during the execution of display list, the box will appear in different places or even will not longer appear. means during the execution of that display list, if you change something, your projection or viewing direction, if you are changing, that is not going to be affected on display list, because already that is executing. You have changed at a client side, you have changed that as a client side, but already you have started executing those display list from the server side. If you do some change in your client side, then it may not be affected on the server side. That is the disadvantage I have told. Among these, other than these 2 points, this disadvantage means states. If you are at a client side, if you have changed a particular state, then that state may not be affected on that display, because those are already predefined. This is what you have to take care of this thing, right? Then how to create a display list? There is a GL unit index, means as I told, every display list has its own identity. Whenever you are creating any display list, you have to create unique display lists, right? To get unique display list numbers, again there is a GL gen list. There is a OpenGL provides one API, GL gen list, means it will give unique random identifiers. Means you are requesting the identifier 1. You are requesting OpenGL identifier 1 for something, means you want to assign that 1 to some display. That's why you are requesting from the OpenGL that give me identifier 1. If identifier 1 means, in this example, GL gen list of 1, means you are requesting number 1 from the OpenGL. If that 1 is freely available, then only that 1 will be returned to you. If already the 1 number is assigned to somebody, then that will not be returned. Means because every display list has its own unique numbers, right? You can take any number, but the unique numbers must be unique. Means you are asking that give me 1 for me, give me 1 to me. I want to use that 1 for my display list. But if it has not given 1 for somebody, means already other person might have requested for 1. If it is already 1 is assigned to that guy, definitely he might have used that 1 in his display list. That time it will not give. If that 1 is free, then only that will be given to you. Then take that 1. If it is free, then it will be given to that index. Means again you can as set of numbers will be normal. It will give a set of numbers. Means always first starting number it will give, then continuously some numbers will be available. Those you can use in your then. Compile the display list, store a triangle in it, right? Compile the display list and store triangle. Means one example, here we have stored a triangle. I have written a display list for writing a triangle. How to write then? Always display list has to be written in GL new list and GL end list. Whatever display list you have to create display list in the 2 primitives. How we have GL begin and GL end, we use it for the primitives like that. Here also there are 2 exclusive APIs are available. That is GL new list and GL end list. In between this you create your list, your display list, right? Then how to create? Then GL new list index. It means you have to assign, as I told, you have to give the unique names for each display list, right? In this example, you are requested for 1, then assume that it has given 1, the index is nothing but 1. Means you are creating display list with the index 1. Then GL compile, again there are constants, there are different constants are there, as and when they will come we will discuss. GL compile, right? GL, one more is there, GL compile something. I'll see then uploads I'll tell, right? Means this GL compile, there are 2 different constants are there, those can be used, right? You are creating the display list called 1 with GL compile property. Then what is that? In that your commands, one triangle you are creating. One triangle you are creating, means GL 3 vertex triangles you are creating. Then GL end, then GL end list, means GL new list to GL end list, one display list with the number 1, identifier 1. One more if you want to create, then create other than 1 identifier, because already you have created, you use the identifier 1 for this display list. Again don't use duplicate numbers for display list, right? Then GL end, then draw the display list. Then whenever you want to draw triangles, what you have to do? Just call this display list. Assume that this display list you have stored in server. Right? Then whenever you want to draw the triangle, just make a request to the server saying that you display this. How to display? Just call GL call list, then index. What is your index? 1. You have assigned 1 for this display. Then GL call list 1. Automatically it calls that this display list. Then this is triangle. Then it displays. Then afterwards, if you want to delete, you can delete. That is a GL delete list. GL delete list index comma 1, right? Index comma 1. This is what, right? Then example, for example, GL matrix mode, GL underscore projection. GL matrix for GL underscore projection for I equal to 1, I less than 5, I plus plus. GL load identity, GL ortho 2D, 2D whatever. Then GL call list box, right? As I told. Again, then what type of commands can be included in display list? You cannot use all the commands available in OpenGL in a display list. It is not possible, right? Again, display list has some restrictions. You cannot use all the commands. You cannot include all the commands available in OpenGL in a display list. There are some restrictions. Some commands cannot be included in GL display list, right? That is, every time that the call GL list is executed, the box is redrawn with a different clipping rectangle, right? Different means whenever you are moving the objects, there are some commands are immediately you have to execute. There are some commands you have to execute immediately. After executing that, then you have to call those some operation, right? Means first you have to set the clipping window, then you have to display the particular object, and that's why this command you cannot include in a display list. Such commands you cannot include in display list, right? First you make this, then you call. That's why there are some restrictions will be there. Some commands cannot be included. That's why this is what first set for this, then you call the display list, right? This is regarding how to create, then how to use display list, right? In next class again we will continue with the display list. Again, the display list I have told here in this class, I have told that there is a GL compile, right? One more mode is there. What is compile? Means GL compile, what it does, it will compile and store the commands. It will compile and store the commands, right? This is what it does in detail. Again we will discuss with different examples. At that time I will explain. Today we will end up this, means how to create display list, how to use, what are the advantage, why you are using display list, what are the input devices, logical devices. Already we have discussed physical properties of those. Then again different modes of logical devices. That part we have discussed. In next video we will discuss the remaining part of input and interaction, right? By this today's session